Uh,
Good evening.
yeah. So today in the session we are going to see few topics like where you're facing more difficulties uh, from week 1 to 4.
Hello.
Hello. Yeah. I'm audible.
Yes, ma'am, you are audible.
Yeah.
Yes.
So we are going to basically revise today from week 1 to 4. So before we start, there is something that I want to discuss with all of you. So I'll just share my screen. Okay. So in your mock paper, so tomorrow is your mock. I hope you have received the announcement. So in the mock and in the quiz paper, so you will see the questions like that in few of them. So the idea for such kind, so see this is the main question. I'm just taking one example from our assignment. So this is a question. So if you have to solve this question and if you get it right, it is fine. Let's say this question is for 3 marks. So if your answer is correct, then we will not evaluate your second question. So the second question is select 3 facts, formula or steps from the list of options that you will be using for solving question number 12. Here it will be like the question number 1. Okay. So to solve this problem number 1, so what all possible steps or facts you are using, right? So there will be some list of options. So here I have put just five list of options. So in your paper you will have many, like let's say a set of 20 to 25 options, from where you will have to select the steps or the formulae or the fact that you are going to use to solve the first problem. So okay, so in the first problem it says x is uniform in 1 2 3 4 5 6. It is a discrete distribution, and x1 x2 x3 are 3 id samples with distribution x. Now what is the probability that 1 and 2 appear exactly once in the sample? So to solve this question, let's say I have used the factor that x is uniform in 1 to k. This I have used. Let's say I have used the third fact that if x and y, if your two events or your two random variables are independent, then the probability will get multiplied. Then I am also using the fact that probability of a complement is equal to 1 minus probability of a. So let's say I have used these 3 facts. So if you write these 3 facts and it is correct, then you will get some mark for this second question. Only in the case if your first question number 1 is wrong, what you have done is wrong, and the second, like this part you have done only if question number 1 what you have done is wrong, then you will get evaluated for the second part. If whatever answer you have received, if that is right, then in that case your second question will not be evaluated. So if you are sure that the question that you have solved, so this is your main question. So if you are sure that this question is right, what you have done is right, then please do not attempt the second question. So only if you are not sure about how to like in some cases you may do the calculation wrong or something. So if there is time, then attempt this, or if you're not very sure, then attempt this. Okay, so this kind of question you are going to see in your mock and quizzes. Is it clear?
Yes, Nick.
For all the quizzes from now on, we will see.
So for quiz 1 it is there. We will let you know if this is there for the next quizzes.
Madam, when mock will be raised?
So mock will be tomorrow from 8 to 9. I hope you must have received the announcement.
Ma'am,
Yes, ma'am, we
there
have
is
received
an
the
ma'am, there's an issue. Max smoke is also there tomorrow between 7:30 to 8:30.
For maths too.
Yeah.
It is a clash.
Is it a time mock?
Yes.
Okay. Okay. I will check then. All right. I will check and I will update today. Okay.
Okay, sure. And one other thing, so this, so totally, how many questions are there in mock? And for all questions, this will be there?
No, not for all the questions, only for NAT type.
Okay, okay.
Not for MCQ, not for MSQ. So only for NAT types, it will be there. So here I have just put the list of options for one particular question. So there you will have, let's say 4 to 5 questions, which is of this kind. So you may have 20 to 25 set of list of options. So that will be there in your question paper at the beginning, like formula sheet also we have shared with you. So what you're going to see in the quiz one. So please have a look and like do not try to remember any formula. So because that will be available. If you remember, it is fine, but you don't try to remember. So
where can we get that formula sheet?
We have posted, it is there on the portal. So you can go to the supplementary content and check the formula file. So there you will get the formula file for quiz 1 and the notes from week 1 to 4. Okay, so that you can check.
Ma'am, could you repeat how do we answer this such questions which have the note this question is optional? Like, are we supposed to answer both? I didn't
No, you are not supposed to answer both. So your main question is this question. Okay, so
Okay.
if you do it correct, if your answer what you have answered is correct, then in that case your second question will not be evaluated. Okay, even if you answer, then it will not be evaluated. But in case you have tried this, or even if you haven't tried this, and if you have tried and this is wrong, and you have also tried the second question and it is right, then in that case we will give you some partial mark for the first question.
Okay.
Okay. So there you will have, let's say here I have put 5 options. So there you will have also many, a list of, let's say 20 to 25 options. And from there you will have to select the facts, formula or steps that you will be using to solve the previous problem. So in this case, it is question number 1.
Okay.
Okay. So you'll have to just, like here also it is not anything numerical, it is just theoretical part. Like it is uniform distribution, then you're using probability of A complement is 1 minus probability of A. So such kind of steps will be there.
Okay.
Nothing of numerical sort. So it is all like facts mostly. Okay. So
yes. Thank you.
Yeah. Okay, so now we'll move to the revision part. Okay, so I will start with your week 4. So many of you are facing problem in finding CDF and PDF for functions of random variable.
Ma'am, are we having one more session?
Yeah, so one more session is on Thursday, which Andrew sir will take.
Okay, ma'am.
And we will have one more mock session.
Ma'am, this pattern which we have just discussed, are we going to have this pattern also in the mock?
Yes, you are going to see such kind of questions.
Okay.
Just a concern, please schedule one session apart from 7 to 9, because usually 7 to 9 will be somewhat working hard mostly. So one session apart from a 7 to 9 session will be helpful.
Like you mean afternoon?
Morning hours, anytime. I mean, in the morning is fine, because most of will be those who have work at 7 to 9 will be available on the morning 9:30 to 11:30 like that. At least one session For a mock, I mean, for a quiz, at least one session, because mostly
Yeah.
7
So
to
for
9 there will be
okay. So
calls.
for mock, we'll put it in the morning.
Yeah. Okay.
Okay.
When will we, ma'am?
It will be on Friday. So you will get the announcement.
Okay. Now we will start with week 4 or go descending.
Okay. So do you want me to
Week
discuss
4.
from week 1?
No, week 4 is good, ma'am. Let us start
Yeah,
with week
like
4.
many students. Yeah.
Yeah.
Okay.
Difficulties.
Can we ask our doubts from week 4?
Not from the questions. If you have any problem, you can ask me. Okay.
Ma'am, in activity questions, I have problem.
We can discuss. Like first, let me discuss the topic, and then we'll discuss.
Okay, ma'am.
Okay.
Can we go from week 1, just intro in a brief about week 1, 2, 3, and then week 4?
All
No,
right.
week 4 is better, ma'am. I think.
Yeah,
No,
Yes,
just
ma'am, week 4
From
is
week
better.
Yes.
3 and week 4.
Yeah, week
Okay,
3
just
and week 4.
just
do a quick summary.
yeah, just hold on for a minute. So I will do a quick revision for week 1 and 2, and then I will move to week 3.
And key
That's
points. Revision of the key
Yes.
points also, ma'am.
Yeah.
Yeah. Okay, ma'am. Thank you.
Ma'am, what will be the question distribution pattern week-wise?
It will be almost uniform. There is no such pattern.
Okay.
Ma'am,
Yeah.
ma'am, would it be possible to put up the pattern for the exam in the discourse as well? Because I joined a bit late. I'm sorry for that. So I could catch the
Okay.
pattern.
Yeah, so it is there, like it is live streaming, so you can always go and see. And we'll also put the announcement tomorrow, so do not worry. Okay,
Thank
so
you.
now we'll start now. So in week 1, we'll have joint distribution, marginal, and conditional. So mostly we are discussing about these 3 topics. So what is the, like this is about week 1 is about discrete random variables. So if we have any 2 random variables, let's say x and y, and their let's say the range of x is t of x, range of y is t of y, then their joint PMF, we write it as f of xy of t1 comma t2, right? And what does it mean? It means that the probability that x is taking the value t1 and y is taking the value t2. So this is like both x and y should occur together. This is what it means. So like for example, okay, I will take the example from the lecture. So let's say you are tossing a fair coin 2 times. Okay, so let's define the random variable xi to be 1 if head occurs and 0 if tail occurs. All right. So if I write, so we are tossing the coin 2 times. So I will take the value which, so I will take the value in 1 comma 2. So what does x1 mean? So x1 means the outcome on the first toss, and x2 means the outcome on the second toss. So if I write fx1 of x2 of 0 comma 0, what does it mean? It means that on the first toss we have the tail, and on the second toss we have the tail. So we can calculate this probability, right? So it is going to be probability of occurrence of tail is 1/2 and again 1/2. Similarly, if I write fx1 x2 of 0 comma 1, it means on the first toss you have a tail, and on the second toss you have a head. So this is what it means by the joint distribution, joint PMF. Now, if we have to find the marginal, so in case of marginal distribution, so if we have xy two discrete random variables, and they have the joint PMF f of xy, then if I want to find the marginal of x, then you will have to add it over all the values of y. So you have to write fxy of let's say x comma y, and you will have to add it over all the values that y is taking. So if x has the range tx and y has the range ty, so this is y belongs to ty. So you will sum it over the range of y. Similarly, if you have to find the marginal of y, this is going to be sum over fxy of x comma y, and you will sum it over x, where x belongs to the range of x. So whenever you have to find the marginal, whether it is for x or y, so if you have to find the marginal for x, you will sum it over the range of y, and if you have to find the marginal of y, you'll sum it over the range of x.
Ma'am, here
y
belongs to ty.
Yeah.
It should be xi belongs to I is equal to 1, 2, 3, 4, or like that. Because we are summing over x now. Or we are summing over y.
We are summing over y. So I will draw the table.
In fx.
Yeah.
In marginal of fx.
Yeah.
We are summing over x.
Yeah, let's see the table first.
Okay,
I will. Okay.
Okay.
So let's say this is your random variable x, and this is y. X is taking the value 0, y is taking the value 1. In x y is taking the value 0, and it is taking the value 1. And let's say this is your okay, let's leave that. So let's say this is your 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So why this is a valid valid joint PMF? Because the sum is going to be 1. Now if I have to find fx of x, it means marginal of x. So I will sum it over the values of y. Like this is your fxy, right? This is your fxy. So what does it mean? It means that probability that x is taking value 0, y is taking value 0. This means probability that x equals 1, y equals 0. So I will sum this row. Okay. So I will sum this row, and it will be 1 upon 2.
The same thing I am saying, ma'am. Here in the formula, fx is equal to sum over y belongs to ty or xi belongs to tx.
Y belongs to ty.
Then it will not change. It is a fixed one for fx. Y will not change. Here we always, what notation we use, just I want to know. If summation is there, then it should be from varying range of the values. No, I think so. If it is
no, see,
xi belongs to tx.
Okay, so this we have found fx, right? Sorry, this we have find fy.
Yeah, y is fixed. Y is not changing at all in
here.
fx.
X is changing. If I am finding, changing,
so we are summing over x.
This is fy. If I am finding fy,
no.
I've written x here.
I am telling the formula, ma'am.
No. See,
summation.
If I am summing it over, I am summing it over x, right?
X, yes.
So if I am finding fy of y, right? So in this case, y is equals to 0. So fy of 0, right? So that is what? That is 1 by 4 plus 1 by 4. You are summing it over the values of x.
That's what I'm telling you. The summation, what notation we use below the summation, what I mean to say. Because most of the time I have seen the value given below summation sign is a varying.
This is, we are talking about marginal here. So please go back and read it again.
Okay.
So
Okay.
if you have,
okay, ma'am.
yeah, any
Okay, I will
doubt?
see.
Yes, ma'am. The X is the number of head, right?
X is the number of head.
And Y is the number of tail.
Okay, I haven't taken that example. Yeah.
So you are putting X 0, 0. So how can it be 1/4? I think it will be 0. You are
What
tossing
is
a coin and you are getting a head and tail also. So how can you write it 1/4?
No, X equals 0 means you are getting a tail. Y equals 0 means you are getting a tail.
No, ma'am. Y equal to 1 mean you are getting a one tail, I think.
No, Y equals 1 means you are getting a head. X equals 1 means you are getting a head.
Oh, so condition is 2 heads, right? X also head and Y also head.
In this case, it is X is first. On the first toss also you have received a tail, and on the second toss also you have received a tail. Your outcome is tail. Okay.
Okay.
Yeah. So yeah, so whenever you have to find the marginal, like if you have to find the marginal of X, you will sum it over the range of Y, and if you have find the marginal of Y, you will sum it over the range of X. Now, if we go to the conditional distribution, conditional PMF, so this is basically, so if you have probability X equals X given Y equals Y, small y, so this is going to be fxy x comma y divided by fy of y. So this is the joint distribution, and that is the conditional distribution. Okay. So this is the formula that you should know. This is the basic conditional distribution formula. So if I take one example here. So this is your X, this is your Y, 0, 1, 2, 0, 1. So this is 1 by 4, 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 4. So here you will have fy of y, and there you will have fx of x. So if I ask you what is the range of y given x equals 0. So given x equals 0, your y is taking the value 0, 1.
0 and 1.
Right? So y will take the value 0, 1. Similarly, given x equals 1, y will take the value 0, 1. Same for 2. Now, if you have to find fy of fy given x equals, let's say 1, y is taking the value 0. So what we can write here as probability that x is taking the value 1, y is taking the value 0, divided by probability that x is equals to 1. So x equals 1, y equals 0. So it is 1 by 8, and x equals 1, it is 1 by 4, right? So it is 1 by
2.
Yeah. So this way you can like if you have a table, if you can find a table, joint distribution table, then it is very easy to calculate such kind of problems. So in week 1, okay. So in in week 1 there is one important topic that you have. So given, let's say you have a random variable that follows the Poisson distribution. So let's say the random variable follows the Poisson lambda, and yeah.
Hello, ma'am.
Yeah, tell.
Y given x equals to 1, then why y take value only 0, not 1?
y is taking the value 0, 1. If x equals 0, if x equals 0,
If x equal 1.
if x equals 1, that case also it is taking the value 0, 1. You can see, right? X
Yes,
equals 1, y is also taking the value 0, 1. Right?
Yes, ma'am.
Yeah. So let's see this topic. So if you have
Probability of x equal 1 is the column sum, right? Column sum of x equals 1.
yes, right. So if you have to find x equals 1, probability x equals 1, so you will so these are the joint PMF, right? So 1 by 4, 1 by 8, 1 by 8. And if you have to find marginal of x, then you will sum it over the range of y. So what are the ranges of y? It is 0 and 1. So it is going to be 1 by 8 plus 1 by 8. So we will sum these two values. If I have to find fx given y equals 1 of 2. So this is going to be what? This is fxy of 2, 1 divided by fy of 1. So what is fxy of 2, 1? X should take the value 2 and y should take the value 1. So that is 1 by 4. This is 1 by 4. And what is fy of 1? So fy of 1 is this, right? So these are the joint PMF, and you have to sum it over the range of x because we have to find the marginal of y. So you will sum it over the range of x, and the range of x is 0, 1, 2. So you are going to add 1 by 8, 1 by 8 and 1 by 4. So it is 1 by 2. So again it is 1 by 2. So these are the very basic things that you should know from week 1. So whenever you get any, even you have some word problem kind of question, you should try to formulate it in the form of a joint PMF table and try to calculate the probability. Okay.
Ma'am, if a table is given
and
the sum of all the PMF is not equal to 1, then we cannot calculate all these calculations, right? If the joint PMF,
Then table must be wrong.
Suppose given table is not, it is not written that this is the joint PMF of the x and y. Only table is given PMF. Then we have to check whether it is joint PMF or not.
So if the table is given, you have to check whether the sum is 1 or not.
Yeah.
Right?
If it is not 1, suppose.
Yeah. So
then nothing. This calculation are not valid, right?
No. So okay, whatever notes we have shared, please go and see once, because it like all the basic things are there. It is like whatever is in the lecture, you have it there. Okay. So
not in the supplementary content.
It is there in the supplementary content.
Okay. When today?
Yeah, today.
Okay. I don't know.
Okay. So our next topic here is like if you have a random variable, let's say n, and it follows the Poisson distribution with the parameter lambda, and this and you have another random variable, another that is x given, another event you have that is given n equals n. If it follows binomial distribution with n comma p, then you should be able to find what is the joint PMF of n and x. So how will we do that? So you must have previously we have seen the formula for conditional and the relationship between the conditional and the conditional, joint and marginal. So we know that if nx, we know that if y given x is same as fyx divided by fx, right? So similarly, this we can write it as f x given n into f of n. Now, okay, before this, I would like to know if anyone wants to know the derivation part of it. Because,
no, ma'am.
No.
How this one?
No, ma'am.
Yeah,
Ma'am,
because
please go with
the
revision flow only.
Yeah, so the derivation is already there in the lecture, and in the for the exam perspective, like you should know the result mostly, right? So I will just go with what is the concept here. So
Yes.
if you have any Poisson distribution and you have another random variable x, if you condition that on that Poisson random variable, and it models, and if that models the binomial distribution, then your distribution for x, okay, then your distribution for x is going to be Poisson lambda p. So this is, you should remember, okay? So if you have any Poisson random variable, and if another random variable condition on this Poisson random variable, if that follows the binomial random variable with parameter n comma p, then the distribution for x is again going to be Poisson with parameter lambda p. So you also must have seen many problems on this concept. So like this is kind of important, okay? So just remember this. If you have problem in derivation, please go back to the lecture and just try to look at it once.
Once f nx is equal to fx given n and fn.
Yeah, right.
Explain this one once.
Yeah, from this formula. So what is conditional PMF?
Okay, got it.
Right. So just
Yeah,
written that way. Okay.
Yeah.
So all right.
This is the basic formula, ma'am. F A given B is equal to the F A intersection F B intersection divided by F B. It's same. Thank you.
All right. Similarly, if you have to check for the independence, so to check for independence,
I'll just ask.
Yeah.
Can you scroll down a bit?
all right.
Just scroll down. Yeah, here you have written right. F of nx equals to f of x given n f of n. This should be f of n or f of x.
This one. Sorry, can you repeat?
This f of nx equals to f of x given n fn.
Yeah.
This will be f of x, right?
No. What formula we have to use here? If x given n.
Yeah.
X comma n.
Yes.
Sorry. Equals n of x. This is f xn of n of xn divided by fn of n. So this
fn.
will go there, right? So whatever you are conditioning on. So here you're conditioning on n. So that marginal you will have to multiply.
Okay.
Look at this formula.
Yeah, ma'am.
Yeah.
Got it.
Ma'am, this expression in words we can in the model we can, if the event n is following the Poisson distribution and the event x is following given based on the Poisson distribution n already happened.
Yeah.
And the both model is following the binomial. Is it so, no?
Yeah, like if x given n is following the binomial distribution, then the distribution of x is Poisson with parameter lambda p. Okay.
Here distribution of x means already random variable n has already happened.
Yeah, right.
Yeah. Okay. Thank you.
This p is same as binomial p, right?
Binomial p. Yeah. Right.
Okay,
So
thank you.
okay. So the next
And
is
directly we can use formula if the model is same.
we'll come back to that again.
Okay.
Thank you. So the next is, if you have to check for independence, so again you just have to check whether your fxy of x comma y is coming out to be fx of x into fy of y or not, right? So in case
for all
Yeah, can you mute yourself sometime?
Yeah.
So in case if for any one of the x and y, if this doesn't happen, then we can directly say that this is dependent. Like these two random variable x and y are dependent, and like if for every pair of x and y, if this satisfies, then we'll say it is independent. So this is the only thing that you will have to remember for independence. Okay, so there is one expression that we have is, let's say you have x1, x2 up to xn. They are all IID geometric P. Okay, so if I want to find what is the probability that x is greater than j, so this expression also we use it many a times directly in the questions. So it's good if you either know the derivation or if you know direct result. So both ways are fine. So if I'm writing, if I have to find what is the probability that x is greater than j. So this is going to be what? This is going to be sum it over. So x is greater than j is same as probability that, okay, again, before doing this derivation, if anyone wants to know this derivation.
No, ma'am. No, I'm just write the formula and just go with the revision flow.
No, ma'am, you can go ahead
All
with
right. All right. So yeah. So in this case, if you have to find probability x greater than j, then you will have 1 minus p to the power j. So either you can remember this or you can know the derivation. So we use this many a times in the problem, so it is good to remember this.
Ma'am, actually, one question.
Yeah.
Like, I mean, like, based on the distribution or the sum, how do we arrive at like whether it is a geometric or Poisson?
Based on the distribution, and I didn't get
No,
it.
say for example, like in one of our graded assignments, we got a sum saying that, like, we get the defective piece. There are totally 3 defective pieces out of the 100. So, and then like, what is the probability of this distribution? So then like,
Okay, yeah, right. So there, your context was like, you are picking up an item and checking whether it is defective or not, right? And you are keeping aside the product once, like you pick an item, if it is defective, you will keep it aside, right? Again, you will pick up an item and you will, if it is defective, you will keep it aside. If it is not, you will just say your first, if your success was getting a non-defective item, like it depends on the success. So you will have to remember what is the geometric distribution models. So it models like number of outcomes when you get the first success, right? So if you have to get the first success on the first trial or the second trial, you will have to check for each step. Like if this is a first trial, whether you're getting a success or failure. If you are taking a second trial, success or failure. So that way we'll have to see what kind of distribution it models.
Okay, ma'am, in case like this, actually, can you brief like how we arrive at this distribution is a Poisson? Like, as you said, like this one, I understand.
Okay,
as,
so
I mean, like
this
the
one
success
is
after this many failures.
Okay, this one is not intuitive. I mean, this one is not intuitive. This is based on the calculations, derivation. So like there is a
Poisson will be given, right? It will be mentioned, right? Only for geometric we can guess. Usually Poisson will be given as a Poisson, right? For lambda value always. It will be mentioned.
Yeah, in the problem it will mention like the parameter.
Yeah, no, for Poisson it will be given directly as Poisson. Only for geometric we can guess at the first success. So we can guess that is a geometric.
Okay, that is also not true. I mean, okay, we'll come back to it. Okay.
Okay.
So let me first finish this. Okay. So
Excuse me, ma'am.
yeah.
This you have that you have written x1, x2 till xn is linearly geometric with parameter p, and then you have written that probability x greater than j is equals to 1
So
minus p to power j.
let's say this is your distribution x.
Yes, ma'am. Ma'am, so ma'am, what I'm saying that Professor Andrews said that the probability that x greater than j is equals to 1 minus p raised to the power jn. And you have written only j.
What Professor Andrew has done is, what is the probability that x greater than j to the power n? So that is 1 minus p to the power jn. Please watch it properly. Okay?
That is
So
when
like
all of
that
it,
you have written
and all of it
See,
becomes great.
see. If I write x1, x2, xn, iid x, what does
Yes.
it mean? Can you tell me what does it mean?
Ma'am, that these all n random variables are independent and identical distributed.
What is mean by that? What is mean by identically distributed?
Ma'am, that ma'am, that they are following the same distribution, geometric, and all they have all
As
have the
x.
same parameter p.
They all following the same distribution. So
Yes, ma'am.
there we have just found probability x greater than j. So this
Okay.
x can be anything, x1, x2, xn. But now we have n samples, right?
Okay, ma'am, I got it. Ma'am, what, ma'am, so you are saying that what professor said that he multiplied that probability x1 greater than j into probability x2 greater than
Yeah,
j.
okay, let's not talk in between. Let me finish. Okay. So if you have doubt, we can take it at the end.
Oh, ma'am.
Okay. So the next is your memoryless property. So the geometric distribution, if you have a geometric distribution, then it follows the memoryless property. So what does it mean? It means that like in definition, we write probability that x is greater than m plus n trial, given that x is greater than m at trial. This is same as probability that x is greater than n. So it means that okay, so if it is given that on emit trial you have the first success, so what is the probability that you will get the first success after m plus n is same as getting the first success after n at trial. So this is
for geometric only, right, ma'am?
This is for geometric, and also it follows the same for exponential distribution.
Yeah, of course.
In the continuous
Yeah,
distribution.
of course.
Yeah, right. So,
Ma'am?
yeah.
Ma'am, there's a small request. Can you please start from week 3 and 4 and then come back to this? Because otherwise the time will not be left. And the notes that you have provided are very extensive. So I think first and second
No,
week.
ma'am, we need on week 2 actually.
Let me just finish this. Small portion is left, so I will come back to it.
You can continue.
By 8 o'clock, I will try to finish this up. Okay. Okay, so one more thing is, like, if you have n Bernoulli trials, then sum of x1 to xn, it models the binomial distribution with the random with the parameter n comma p. So I hope it is clear why x1 plus x2n is binomial np. Then there is one thing that that will be needed to solve many problems. So if you have sum of two random variables, let's say you have xy, and it has the joint distribution fxy, and you have another random variable defined that is equal to x plus y. So what is the distribution of z? So to find the distribution of z, what we will write? We will write z equals x plus y. This is equal to z. So this is same as writing that probability x is taking some value x and y is taking some value z minus x, and x is taking the value from minus infinity to infinity. Let's say the range of x is r and the range of y is also r. So this, in case if x and y are independent, then we can write it separately. Probability x equals x into probability y equals z minus x. But in case if they are not independent, then we'll write it as fx of y, and x is taking values x and y is taking the value z minus x. So whenever a problem like this comes, like you have given a joint, like you are given the joint distribution, and you have the sum of those two random variables, and you have to find the distribution of z. So let's say x and y was following the geometric distribution. X and y were following the geometric distribution, geometric P. So we know that the range of x, never forget the range, never forget to write the range for the random variable. So if you have the geometric distribution, the range of x and y will vary from 1 to up to infinity, right? So whenever you have to solve a question like this, then you should take care like from where you should start the starting value, the range of x, and where you should end. So if so let's say if x and y are geometric, so I should start x from 1, and where should it end? So y should not go to 0. So y should be less than y should be less than sorry, y should be equal, y should go maximum till 1, minimum till 1, right? So we should put the value of x in such manner. So this you should take care of.
Once more, ma'am, please. Once more. How to take the values here?
Yes.
How did you define the y range actually?
Sorry.
How did you define the y range actually?
No, I am saying that x and y, x is geometric P and y is also geometric P. So the range of x and y both should vary from 1 to infinity.
Yeah,
right?
so the range of z also should be 1 to infinity, right?
Not necessary.
2 to infinity.
2 to infinity.
Z equals to x plus y, right? 2 to infinity it should be.
No. So x should start from 1, right?
Yes, ma'am.
So
and y is
this,
also 1.
y can go minimum till 1.
2. Yeah, so z is from 2 to infinity.
What you're saying?
Ma'am, the range of x is equals to 1 to infinity. Range of y equals to 1 to infinity. Minimum value of x comma y equals to 1 comma 1.
So okay. Yeah, so it will go minimum till 1. Sorry, 2. Right.
2 and maximum is infinity.
No, there we are writing for x, no? I mean, for what value of x you should take so that y doesn't go below 0. Sorry, below 1. You must have seen some problem in your assignments. Okay.
Right, ma'am. Okay. So x
right?
value is maximum z minus 1.
Yeah, right.
Yes, ma'am. Got it.
Yeah. Right. So, okay. So again, if you have like you have two random variables x and y, and if you have to find the distribution of x plus y, where x is again Poisson with parameter lambda 1 and y is also Poisson with parameter lambda 2. So if we have to find the distribution of z equals x plus y, then it comes out to be then this distribution comes out to be Poisson lambda 1 plus lambda 2. You just have to add those parameters. So again, Z will come out to be Poisson distribution with the parameter lambda 1 plus lambda 2. So again, the derivation part you can see in the lecture if you have doubt. And similarly, if you have to find the distribution for X given Z, or let's say Y given Z, so this distribution, the distribution of X given Z, comes out to be binomial with parameter n, comma, lambda 1 by lambda 1 plus lambda 2. So the parameter of X was Poisson lambda 1. So that's why in the numerator part is coming lambda 1. That's how you can remember this. And the distribution for Y given Z will come out to be binomial with parameter n, comma, lambda 2 by lambda 1 plus lambda 2. So this also you can keep in mind.
Ma'am, will these formulas will be given, or we have to?
No.
Do we have to memorize?
If you know how to derive it, it is good.
Okay.
But
So these kind of things will not be given, right?
No, not. So it just go and check once what all what all is there in the formula sheet.
Where do we find the formula sheet?
It is under the supplementary content.
Ma'am, if n changes, how the formula changes?
If n changes,
Like if x and y has different n values, right? M and n.
okay, so this n is not coming from X and Y. So if Z is taking the value n, then X given Z is binomial n, comma, lambda 1 by lambda 1 plus lambda 2. So in case if Z takes some other value, let's say m, so it will come out to be binomial m, comma, lambda 1 by lambda 2. So this is given Z equals n.
It is better to take n in place of n. We can take m or other value. Then z is equal to m. Then m lambda 1 by lambda 1 plus lambda 2. No? We can take.
Yeah, if you take Z equals m, it will come out to be binomial m, comma, lambda 1 by lambda 2.
It is better to remember.
Yeah. So one more thing is
m is different from n other one given.
Yeah, right.
Yeah.
So okay.
And what will be the case for x times y, like xy?
X times y. So
Z
you can
equals
try
to
to,
xy.
yeah, you'll have to derive.
Okay.
Like it is not very straightforward. Yeah.
Okay.
Yeah. So one more thing you have is like if you have a random variable x that is that has a distribution binomial np, and the random variable y that follows binomial m, comma, p, and if x and y are independent, then the distribution of z equals x plus y is same as binomial n plus m, comma, p. Okay, so now we'll move
So
to.
if n is different, then it will be Poisson. If n is same, then it will be Poisson, or else it will be binomial, right?
Which one you're talking about?
This left and right.
Left hand side.
Left hand side is z equals to x plus y, where x and y both are in
Both are Poisson.
n, right? N comma p, n comma lambda. Okay.
No, they are Poisson.
Okay, on the left hand side, x and y are both Poisson with different parameters. Okay, on the right hand side, x and y are both binomial with different parameters.
Okay,
nm.
got it.
Okay.
In the second case, ma'am, x and y are binomial np and np. X and y are independent. Then z is equal to x plus y becomes binomial, right?
Yeah, binomial n plus m, comma p.
Okay.
Okay, so from week 2, mostly you have minimum and
here.
yeah.
Just go upside. If suppose x and y are the binomial with different probability, p and q's, for example, then what is z? Means the distribution for Z, what we take the probability here for Z variable.
Okay,
Because the X
you are
and
asking there, right? Okay, let me see that. I will check and tell you. Okay. Okay, so in week 2, mostly we have minimum and maximum of random variable. So there was one session where we have discussed a lot about min and max. So I will just go through it quickly here. So if you have again 2 random variables x, y, where the distribution is fx, y, and you have another random variable, function of random variable x and y, that is defined as minimum of x comma y, then the distribution of fz is same as probability that minimum of xy equals to z. So what is mean by that minimum of xy equals z? So either both x and y will take the value z. So either both x and y are taking the value z, or x is taking, sorry, either both x and y are taking the value z, or x is taking the value z, and since it is minimum of 2 random variables, so if x is taking the minimum value, y should take the value more than z. So y should be greater than z. Or one more case possible is probability.
Y is equal to z and x is equal to greater than z.
Yeah, please don't speak in between. Yeah. So either one case can be your y, you fix your y to be equal z, that is minimum. So in that case, x should be greater than z. So these 3 cases are possible, and in order to calculate the probability, you can add this up. Okay, so this will be summation. Now, in case if you define z to be max of xy, so if you have to find max of xy, then in that case, so probability that maximum of xy equals z. So both x and y, either both x and y will be equal to z, or if x is your maximum, then y should be less than z. And in case your y is maximum, then x should be less than z. So that will be the case when z is maximum of xy. So the distribution will vary a little. Okay. So this is the distribution for maximum of xy.
Again, it will be the summation of all such possible combination, right?
Yeah, right. Okay, so similarly,
Yeah,
if
ma'am.
you,
And to find out the x less than z, we will do 1 minus x less than z to 1 minus x greater than z, right? That's how we solve it.
in case if x and y are independent, then
Because
you can,
most are in that form, right? X is greater than z. So
okay, I think you are asking probability x greater than z equals 1 minus probability x less than equal to z.
yeah, that is how.
Yeah, so this you can write if x and y are independent. So if x and y will be independent, you can write it as probability x greater than z into probability y equals z, right?
Yeah.
Now, in case you have, let's say, n random variable, x1 up to xn, and they are IID x, and you have to find the CDF of max of x1, x2 up to xn. Then in that case, how do you find the CDF of, let's say this is equals z. So how do you find the CDFs? So the CDF definition will be f z of z, and this is same as probability that z is less than equal to z. And what is capital Z? It is maximum of x1 to xn, and this is less than equal to z. Now, we are saying that maximum, whatever the maximum is among the samples x1, x2, xn, this is less than equal to z. So if the maximum is less than equal to z, it means that each of the samples are going to be less than equal to z. So we can write this as x1 less than equal to z, x2 less than equal to z, up to xn less than equal to z. Now again, since all of these xi's are IID x, so if all of these xi's are IID z, then in that case we can multiply all the probabilities. So we can write probability x1 less than equal to z up to probability that xn is less than equal to z. And since all are IID x, so we can just write this as x. So probability x less than equal z to the power n, and this we can write it as fx of z to the power n. So this will be the CDF for your random variable z, that is maximum of x1, x2 up to xn. But now if we have,
do we not lose finding the maximum between the second and the third step? I mean,
sorry,
do we not lose finding the maximum between the second and the third step? How are we finding maximum between the second and the third step?
So this is our second step.
Yes, and this is the third step below it.
So
between this, how that maximum thing is still intact. In the second step, we are saying maximum between x1 to xn.
Okay, let's say I have x1 to be 1, x2 to be 2, x3 to be again 1, x4 to be 5, and x5 to be 3. So if I have to write maximum of these samples, so what is the maximum here? X4?
5, x4, right.
X4, right? So if this is less than equal to z, so doesn't this mean that all of the xi's are coming out to be less than equal to z? Let's say our z is let's say 6.
6, yes.
Or let's say 5.
Correct.
So, or if
if
x4 is maximum, if any of your random variable is maximum, then in that case the other random variables that you have is also going to be is also going to take the value less than that z.
Correct, right. So that is what this is understood. Now, are we not supposed to find probability of x4? I mean, amongst the set x1, x2, x3, x4, x5, the probability of finding the maximum, which should be less than 6. So over here in the third step, we have moved to probability of each being lesser than 6.
Yeah,
right. But where that maximum is coming now, on the right hand side that you have shown, the probability of x4 lesser than 6 is understood that we are finding of the set just one variable which should be less than 6.
Let's say this small set is
that is what now I am able to understand, right?
Okay, so our small set is 6 here, let's say
6,
right?
Right.
So f set of 6, if I write here 6, right? So and in this case, as we have seen here, that x4 is the maximum, right? So if x4 is less than equal to 6, doesn't this mean that all of the xi's like x1, x2, x3, x5 is also less than equal to 6? If something is maximum, then every number that is less than maximum is also going to satisfy that property. So if the maximum is x4 and if that x4 is less than some z, then all of the xi's that are taking the value smaller than z are also going to satisfy this property.
Yes. Okay. So that's where we just calculate x1 to xn minus 1 and then sum it up. Okay.
Yeah. So now if we have in place of maximum, if we have to find the CDF for minimum of x1 to xn, let's say this is Z. So how do we go about this? So probability that Z is less than equal to Z, and this is same as probability that minimum of x1 up to xn is less than equal to Z. Now in this case, our minimum is less than equal to Z. So if a minimum value is less than equal to Z, can we say that each of the values, each of the random variable will take the value less than equal to Z? Is it possible?
Yes, ma'am.
No, right? It is not possible.
No, ma'am.
Like if
No, the sign will be inverted, right? The greater than equals to Z.
No, I didn't ask that. I asked if the minimum is less than equal to Z. If the minimum of the random variables are less than equal, if the minimum is less than equal to Z, that doesn't mean, let's say the minimum in this one is, let's say x5. If x5 is the minimum and it is less than equal to Z, we cannot say that xx will also be less than equal to Z.
No, all the
It is
all
possible.
Yeah.
It is possible that your x2 is greater than equal to Z. Your x6 is greater than equal to Z. All these are possible.
All the values are greater than.
Yeah. So what we do in this case is, so this is a random variable Z, right? So we'll use the property that probability Z less than equal to Z. It is same as 1 minus probability that Z is greater than Z, right? But so if we write Z greater than Z, what is Z? Z is minimum of x1 to xn greater than Z. Now, if the minimum is greater than Z, so if the minimum value is greater than Z, it means all of the xi's will come out to be greater than Z. So this is going to be probability that x1 should be greater than Z, x2 should be greater than Z, up to xn should be greater than Z. Now again, these are all IID, so I can write probability x greater than Z to the power n. So this is going to be your CDF for the minimum of random variable.
From first step to second step, once again, from first to second, 1 minus p.
Yeah. So see, this is a random variable. Like if you have a random variable, let's say you have some event, let's say some event A, right? So if I have to find probability of A complement, what do we write? We write 1 minus probability of A.
Yeah, that is fine.
The same thing we have done here. So this is your, let's say, one event. So this is going to be 1 minus probability that Z is greater than.
We have just written probability of Z less than equal to Z is equal to 1 minus probability of Z greater than equal to Z.
Yeah, right.
And
not greater than equal to, because it is a discrete random variable.
Yeah.
Right.
So we have taken probability of meaning of that, right?
Yeah, right.
Okay, thank you.
Now you have okay. Now if you have two random variables x and y, so if x is your geometric p and y is also, let's say, geometric p, and both x and y are independent. Both x and y are independent, and we are defining another random variable Z that is minimum of x comma y. So what is the distribution of Z going to be? So using the same method again that we have used here, we'll go through the same method and you will obtain this distribution to be equivalent to geometric distribution with probability 1 minus q.
Okay, that's actually the point here, David. You will find that on the back side of.
Yeah. Okay, so there is nothing more in week 1 and 2. So
Ma'am,
we'll
x and y both having the probability same p.
Yeah, And the other case that you can have is like if x is
How this and the previous problem is similar. Here, minimum of x and y is z. So x will be greater than z, right? Greater than equals to z, and y is
no,
equals to
I am
greater than
saying
equals
the previous as in this one. Like if you have to find the distribution of minimum, you can go through the same method to find it.
Actually, this will be the 1 minus previous value, distribution value. So this will be probability of x greater than z, right? To the power.
I didn't get you. Okay, so if x has the distribution geometric t and y has the distribution geometric q, and if we have to find the distribution for minimum of x comma y, this distribution is going to be geometric 1 minus e into 1 minus q. So this will come out to be distribution for.
If it is different, then we PL.
Yeah.
1 minus p and 1 minus q.
Yeah.
Left side, what is q, ma'am?
Sorry.
In the
Q is
left
the
side.
parameter. Q is the parameter, like
No,
probability of.
left side. When z equal to minimum x comma y.
Oh, I have written Q here. So Q is okay. Sorry. Yeah. So this is same as geometric 1 minus p whole square. It will be just this one. So 1 minus p into 1 minus p. That's one.
Okay, q is not there. Right?
No. Oh, sorry. Yeah, sorry.
Okay.
Okay. So we have already discussed many problems from minimum and maximum of random variables. If you want to look at the problems, you can go back to that live session and just check. Okay. So we had discussed many problems.
Can we skip to week 4 now?
Yeah, so week 3, I will just take Markov and Chebyshev and then we'll go to week 4. Okay, because in week 3, there is nothing much to discuss. It's just expectation, variance. So I will not go there. Okay, so from week 3, you just have to remember these formulae. So if you have a random variable x, then expect, and the random variable x has the distribution fx, then expectation of x is going to be sum over x time fx, where x belongs to t of x. This is in case of discrete. If you have the continuous random variable, if x is a continuous random variable, then in that case, in place of summation, you will do the integration. So x time fx dx, where x belongs to the range of x. We'll write support of x. Similarly, for variance, if we have to find the variance of x, this you can write it as expectation of x square minus expectation of x whole square. So using this formula, it is always easier to calculate the variance. Now, if you have to, okay, so the third is like if you have a function, you have a random variable x and you have a function of x, that is g of x. And if you have to find the expectation of gx, then you will have to do, if it is a discrete, if x is a discrete random variable, then in that case, it is going to be gx time fx, where x belongs to the range of x. And if it is a continuous random variable, you will do the integration. So integration g of x into the distribution of x. So this is going to be an expectation formula. So many students do the mistake here. So just keep that in mind. If you have a function of random variable, then you do the integration in case it is continuous random variable. So you take integral of gx into fx dx, distribution of x. Same
Normally,
with
only we have to take the functions which are defined for that interval only.
For x, yeah.
Yeah, integral up to that only.
Yeah,
not
right.
Minus infinity to plus infinity is
No,
not required here.
whatever range you have,
Yeah.
you will integrate or sum it over that.
Okay.
Now the few of the properties here, that expectation of x plus y, this is always equal to expectation of x plus expectation of y, but variance of x plus y is only equal to variance of x plus variance of y if x and y are independent. Then third is expectation of x into y is equal to expectation of x into expectation of y only if x and y are independent. Now expectation of a times x comes out to be a times expectation of x, and variance of a times x comes out to be
a
square times variance of x. So these are the only things that you should keep in mind, like the formula that you're going to use for expectation and variance. You won't need anything else.
When expectations are x and y are not independent, then we have to calculate separately by calculating the functions of x, y, right?
Yeah, okay, I'll explain that. So
okay.
Yeah, please mute. In case they are not independent, they, like, let's say if x and y are not independent, then if you have to find expectation of xy, so what you will do is you will have to find the distribution of x first. So that is not very easy to calculate. So only if they are independent you can do this. Same for variance and expectation. So the next start, yeah, please mute yourself for something. Yeah, I will, if you have any doubt you can ask me at the end. I will take your doubt. Okay, if I'm speaking, don't speak in between. Now you have two very important inequalities in this week, that you have Markov and Chebyshev's inequality. So what does the Markov inequality says is, like, if you have a random variable x with the expectation, let's say mu, then probability that x will be greater than or equal to some real number that will be less than equal to expectation of x by c. So this expectation of x here is mu by c. So it gives to the bound that your random variable x is taking a value, is taking some value greater than c. Random variable x is taking the value greater than c. So this probability should be less than equal to expectation of x by c. So this is what the Markov inequality says. Now you can also prove, okay, so I will write the Chebyshev's inequality first. So in case of Chebyshev's inequality, if you know what is the variance also for the random variable x, let's say if you have a mean mu and variance sigma square, then the Chebyshev's inequality states that probability that mod of x minus expectation of x less than equal to mu, okay, sorry, less than equal to k sigma is less than equal to 1 upon k square. So here sigma is your standard deviation for x and k is your some constant. Okay, so what does this say is, okay, I will also write two more forms of Chebyshev's inequality. So whatever seems easier to you, you can use in the exam. So the second form that we can write it as, this is probability that mod of x minus expectation of x greater than equal to k sigma is, sorry, there's a mistake here. So this is greater than equal to k sigma, and this is less than equal to k sigma, and this is greater than equal to 1 minus 1 upon k square. And the third form that you can remember is probability that mod of x minus expectation of x greater than equal to c is less than equal to variance of x upon c square. So you can use any of these inequalities in your problem depending on the context of the question. So there will be some problems where you will find the first definition, like first inequality to be easier to solve. There will be some where second one will be easier. There will be some where third will be easier. Right? So depending on your comfort zone, you can use any one of them. So if you look at the first inequality, so what does it say is, like if you have a random variable x and it is centered at the mean mu, right? So this is probability that your random variable lies beyond this range, that is mu minus k sigma to mu plus k sigma. So the probability that your random variable lies beyond this range, so this is going to be less than equal to 1 upon k square. This is what, so it basically gives you the upper bound, right? So this first inequality gives you the upper bound, right? Now if you look at the second inequality, so it says the probability that your random variable x lies in the range mu minus k sigma to mu plus k sigma is greater than equal to 1 minus 1 upon k square. So as your number of samples, so in this case here, okay, in Chebyshev's inequality we just have here one random variable. So basically the idea is if you have more and more random variable, and as your number of samples increases, then with probability almost equal to 1, your random variable lies in this range mu minus k sigma to mu plus k sigma. And the third one is just it is obtained from the first one, and even you can derive everything from each other, so it is fine. Any doubt in Markov and Chebyshev?
No, ma'am.
Just that upper bound, not just say once more, please. Upper bound, lower bound concept.
Yeah. So this probability should be less than equal to 1 upon k square, right? So it is basically giving you upper bound on upper bound on the probability, right? I mean upper bound. Okay. I mean, it is giving an upper bound that x is lying in this outside this range. So it can go maximum till 1 upon k square.
Okay, thanks.
Okay, the probability, the bound can go maximum till 1 by k square. In the second case, it can, so the probability is greater than equal to 1 minus 1 by k square. So the probability that your random variable lies in this range should be at least 1 minus 1 by k square. So it gives you a lower bound.
Okay, thanks.
Yeah.
Ma'am, how do we locate the problem to apply the right equation, whether Markov or Chebyshev? Because
so
unless the problem is mentioning,
no, it will be always mentioned in your problem. Like you have to use the Markov. Yeah. So
like in the distributions, there is no mention about which type of distribution we got to go.
Yeah.
So we have to really infer out what is the right applicable distribution.
So there you have some insight, like on what situations it is going to model the binomial distribution, like in which situation it is going to be geometric, like you have some insight, right?
Yeah. Is there any chance of really you are touching base on that type of indicators in the given problems?
So whenever it asks you to find the bound, so mostly if you look at the Markov inequality, if you only know the mean, right? So then in that case, Markov inequality will go better. right? Because you don't know the variance here.
Okay.
So
That's one indicator.
yeah, basically it
Okay.
is always mentioned in the problem, but if it is not mentioned, if you just know the mean for the distribution,
right,
then in that, yeah.
Ma'am, what if P of mod x minus ex equals to k sigma, right? The Chebyshev number 1.
Greater than equal to k sigma, right?
Yeah.
This
So
one.
if I want to take equals to k sigma, then this will be 1 by k square also, right?
If you take this is k sigma, right? So this is just these point mu plus k sigma and mu minus k sigma. It doesn't say anything about
this is actually on the
so okay,
both k sigma lines
if you write x minus expectation of x mod equals k sigma. So what does it mean? It means x minus mu equals k sigma. So it means x equal mu plus k sigma.
Yeah.
And if you take minus x plus
Yeah.
mu equal k sigma, then x equal mu minus k
minus
sigma.
k sigma.
So basically you want to know what is the probability that x equal mu plus k sigma and
It's
probability
equals
that x equal mu minus k sigma.
Yeah, then it will be 1 by k square, right?
It will be 1 by k square.
If I
But
equate on the left hand
equal
side,
equal is there in both the
Yeah.
equations, no? 1 and 2.
Yeah, it is there.
same will apply to equation 2
Yeah,
also.
yeah, it will apply, right? It will apply.
Then my k is coming as root 2 for every value.
Root 2 for every what do you mean every value?
See, for if mod of x minus expectation of x equals k sigma, then 1 and 2 will be similar. The probabilities, I can equate them. So 1 by k
Yeah,
square
in
equals to
that
1 by
case,
1 minus k square.
yeah, in that case, they will come out to be equal.
So,
Side will be what? 1 by k square or 1 minus 1 by k square? At an equal to situation.
yeah, if these are equal, then for every k, my probability will be same.
For every k, probability will be same. So both are Chebyshev's inequality. I mean, you can derive the second one from the first one. It is nothing but the first expression. Like they are not different. They are all same. It's just a different way of writing it.
Okay.
Yeah, like you can try to derive the second.
Ma'am, what I'm trying to say is 1 by k square equals to 1 minus 1 by k square, correct?
No, what I'm saying is like the second inequality and the first inequality both are same.
So
it
is converting from less than to greater than, then
Yes,
your
that is the only thing is happening here.
Okay.
I mean, they represent the second one gives you the lower bound. So the probability that
actually in both the cases equals to is included. X minus
yeah. So in both the
cases,
it will come out to be you said root 2, right? K for k equals root 2.
Yeah.
So it will come out to be half.
Yeah, that is.
Can we say
yeah,
the second one is the complement of the first one?
Second one is the complement of the first one.
Right, ma'am, complement.
Yeah, it is the complement. Like if you try to derive the second expression, you will write it as a complement.
What he's trying to do is he's saying that the first equation, there is the equal to sign in both the equations, right? So he's trying to equate 1 minus k square to 1 by k square to 1 minus 1 by k square. So from that he's getting the value of k as root. So what does that make? How does that make sense? Is what he's trying to ask.
Oh, okay.
Hello, ma'am. What is the significance of k here? Hello.
Yeah.
What is the significance of
k
here?
K is like if I ask you one standard deviation or two, like what is the probability that x lies within the one standard deviation? In that case, k is equal to 1. if I ask you what is the probability that x lies in the second standard 2 standard deviation, then k equals 2. So this is what it means. So yeah, coming back to your question.
Excuse me, ma'am.
Yes.
Can I ask something? Ma'am, why we are talking about equality, ma'am? Here is the name is inequality, ma'am. Why are we talking about equality, ma'am?
No, that is fine.
So only in case of k equals under root 2, this will be equal. If we read Chebyshev's inequality, only if k is equal to root 2, then the probability of x minus ex will be equal to, in both the cases, with this sigma. If it is nowhere under root 2, then it will always be unequal. Only if it is under root 2, then k,
Okay, so you were
both the
trying to say
values will satisfy.
you were trying to say that in what case both these probabilities, like probability that x is mu plus k sigma and mu minus k sigma, okay, like both of these will give you the same value, right? This is what you were trying to say.
No, his question would be if it is equal. If it would be equal, then 1 upon k square is not equal to 1 minus k square. Right? That is when he was asking if both the inequalities involve equal to, then how can this be possible? So it will be only possible if k is equal to under root 2. Only in that scenario this will happen.
Sorry
If
to
the
interrupt.
value of k is other than root k, then it will not hold, is my understanding. You might have.
Sorry to interrupt over
Actually,
here.
when
This
value of k
inequality
is root 2.
doesn't have
Please
equal.
speak one by one. Yeah,
Yeah,
still.
sorry. Yes, ma'am.
Yeah.
If I'm not wrong, but there is no equality sign within the brackets of that mod x minus ex greater than or less than would be there from k sigma, not equal to.
No, equal to is there.
Actually, what root 2 means is the 50% of the data will lie between 1.41 times of sigma value. So 1.4 sigma there, and so within 2.8 sigma value from mean, 50% of my data will lie right now. That is 1 and 2. If I equate, that will.
Oh, that the first one.
Yeah, if I equate 1 and 2, then I'll get k value as root 2. And for root 2, I can say that if like below sigma, k sigma, and above k sigma, both the are equal. I mean, data which are lying inside k sigma and outside k sigma are equal.
Okay, we'll come back to this at the end. Okay, let's keep this here. We'll come back to this. Okay, so in week 4, we mostly have CDF, PDF, and function of random variable.
Ma'am, excuse me, ma'am.
Yeah.
Ma'am, before going through the concept, can I ask my activity doubts?
No, you can ask after this.
Okay.
Yeah. Okay, so we'll first take one problem. So let's say your PDF you have a continuous tandem variable, and your PDF is defined as C of x for x lying between 0 to 1, C for x lying between 2 to 1, minus Cx plus 4C for x lying between 2 to 3 and 0 otherwise. So, okay. Okay, so your first question here is find the value of C. So can you all try this out? Can you tell me what is the value of C you will get?
I mean, it is a PDF or a CDF?
It is PDF. It is written small f. So I will just give you 1 minute to do this. Okay, do it fast.
One by 4.
Okay, so
2.2.
one answer is 1 by 4. One is 1 by 2.
No, ma'am, 0.2. That is 1 by 5.
1 by 5.
1 by 5 is the answer. Yeah.
1
by 5, ma'am. Sorry. 1 by 5.
Okay. Okay. So what you have done here? So how do you find the value of C?
As PDF, so I did all the probabilities equated to
Right.
1.
So it should sum it over to 1 fx dx if you integrate. So you will have to integrate, as you know, the property for PDF that if you integrate it over minus infinity to infinity, it should give you 1. Now in this case, x starts from 0 and x from other than 0 to 3, you have 0. So we can skip that part. So we can just say that integral fx dx, so cx from 0 to 1 dx plus integral 1 to 2 c dx plus integral 2 to 3 minus cx plus 4c dx, that should be equal to 1. So if you integrate, you will get cx square by 2, 0 to 1 plus cx 1 to 2 plus minus cx square by 2 plus 4c x 2 to 3. This is equal to 1. So this is what? This is c by 2 plus c.
Without doing the integration, we can directly say if as Cx is the straight line value between 0 to 1, I mean, whatever the value will be between 0 to 1, the value will be Cx. So we can directly say Cx times width of this, so 0 to 1, so 1 minus 0. So that will be Cx times 1.
Okay. Yeah, but this is your continuous tandem variable. I mean, you'll have to find the area, right? Okay, let's first finish this. So this is plus. So x is what? X is 3. So 9c by 2, that is minus 9c by 2, plus 4th is a 12c minus 4 by 2. So minus 4c by 2 plus 8c, right? So this is equal to 1. So c by 2 plus c minus 9c by 2 plus 12c plus 4c by 2 minus 8c, this equals 1. So if you solve it, you will get 12 minus 8, 4, 4 plus 5c. Now 5c minus, 4c by 2. This equals 1. So 10c minus 4c, this is 3c by 2. Sorry, 6c by 2 equals 1. So c is coming out to be 1 upon 3. I don't know how you solved. Nobody got 1 by 3?
Yes, ma'am.
You had got 1 by 3?
Yes.
Yes, ma'am. 1/3.
You should have told, no? Okay. So the value of c that we are getting is 1/3. So please do the integration properly. The basic integration, I hope you all know. So take the limit properly, do the integration, do the calculation properly also. Do not mess with the plus minus sign. So the properties of PDF says is like it should integrate over the whole range, it should integrate to 1. Now continuing with the same PDF. So now you have to find the CDF of fx. Find the CDF of x. So remember, c is taking the value 1/3. So first you try to solve it, and then I will tell you how to do it. Okay.
What the hello question, ma'am? Find the
Yeah.
value of.
So this is your question.
Okay, find the value of c. Yeah.
Find the CDF of x. CDF of x.
The CDF of.
Right.
Excuse me, ma'am.
Yeah.
Ma'am, one question on expectation, ma'am, can I ask?
First do this.
Ma'am, one different question. Not
No,
from this.
I am asking you to solve this question.
Okay.
Like given a PDF, how do you find the CDF of x? First do this, then we will discuss how to do it. First to try to do it. You can raise your hand if you are done. Okay. Prashanti Singh, you're done?
Yes, ma'am. First is x square by 6, then ma'am 1/3, then minus x square by 6 plus 4/3, and then 0.
No, that is wrong. Rahul, can you tell your answer?
Yeah, ma'am. The first one is 1/3, the second one is 0, and the third one is minus 1/3.
No, that is wrong.
Madam, CDF will be the.
Your voice is breaking. Mute yourself. Yeah. Okay.
Is the CDF going to be the addition of all the
yes.
So it's just 4/3. Is it 4/3?
It is not 4/3. Okay. So.
Oh yes,
you are missing something.
Yeah, no, I just did the integral wrong. I'm sorry.
Okay.
Ma'am, for x less than 1 and greater or equal 0, it will be x square by 6.
Right.
And for x less or equal to greater than 1, greater or equal 1, less than 2, it will be x/3 minus 1/3.
No, that is wrong.
Is it equal to 1?
Plus 6 plus x/3 minus 1/3.
First one is x/3.
X square by 6 plus x/3 minus 1/3.
Yes.
For x less or equal to and greater than 1.
Okay. Who was there? Who was speaking?
Is the answer? Sorry.
Okay. Can you repeat again?
X is for x less or equal to greater than 1, it will be x square by 6 plus x
so
by
for
3.
less than 0, it is 0. For x lying between 1 to 0,
it will be x square by 6.
Okay.
And for 2 to 1, it will be x square by 6 plus x by 3 minus 1 by 3.
X square by 6 plus
x
minus,
by 3 plus x minus 1 by 3, yes.
right?
And for 2 to 3, it will be x minus x square by 3 plus 4 by 3x plus 4 by 3 minus 8 by 6. I didn't solve properly.
Okay, so yours
This is
like
last one,
the,
5x minus 11 by 3.
okay, so none of this is like this is somewhere close but not
4x, ma'am. In the last one, 4x by 3.
X square by
okay,
2.
so okay, so now everybody just listen
Minus
to me
x
now.
square by 6 plus
Can
4
I
by
say, ma'am?
3x.
X by 6, x by 3, and minus x square by 6 plus 4 by 3x.
No, that is wrong. So now listen to me.
Okay.
So I will just write the PDF here. So given a PDF, how will you find the CDF? So this is what we are trying to do here. Given PDF, how to find CDF? So our PDF was fx equals, okay, right here, fx equal x by 3 after putting the value of c for x lying between 0 to 1. For it is 1 by 3 for x lying between 1 to 2. It is minus x by 3 plus 4 by 3 for x lying between 2 to 3 and 0 otherwise. Okay. So how do you find the CDF? So to find the CDF, let's say first we are finding for x lying between 0 to 1. So if you have to find the CDF, you will first write for x less than 0. For x less than 0, it should be 0. And for x greater than 3, it is going to be 1. These are fixed. Now you'll have to find x lying between 0 to 1, x lying between 1 to 2, and x lying between 2 to 3. So if you have to find the CDF for x where x lies between 0 to 1, so sorry, so fx of x is what? This is probability that x is less than equal to x. So to find the CDF, you do the integration of fx, right? So you don't even need to write this. We'll just write integral of fx of x we'll write integral of fx of x dx, where x is lying between 0 to x. Okay, so for 0 to, first we are talking about the interval 0 to 1. So in this case, so you will take the integral from 0 to x. So what is fx here? It is x by 3. So x by 3 dx from 0 to x. So if you do the integration, you will get x square by 6. After substituting the limit, it is x square by 6. So we will write here x square by 6. Now, if we want to find for the interval x lying between 1 to 2, then in that case, you will have to do the integration fx of x, that is, in this case, it is 1 by 3 dx. X is lying between 1 to 2, so we'll write 1 to x plus this, right? So plus x square by 6, where you should take x to be 1. So whatever integration you have done here, so you will write the previous, for the previous interval 0 to 1, you will write x by 3 dx limit from 0 to 1. So this will come out to be 1 upon 6. And if you solve this, you will get x by 3 and limit from 1 to x. So that is x minus 1 by 3 plus 1 upon 6. So for the range lying between 1 to 2, it is x minus 1 by 3 plus 1 by 6. Now, if you have to find for interval 2 to 3, what you will do? Can anyone tell me?
It will add the probability that add the function like x square by 6 and this x minus 3 by 3, x minus 1 by 3 plus 1 by 6, and then
Yes.
for the next one that we got after integration.
Yes. So you will integrate this fx over the limit 2 to x, and then you will have to add these two probabilities. So add these probability here. Okay. So that will be your this fx from fx of s for x lying between 2 to 3. So if you will solve this, you will get 4x minus so 4x by 3 minus x square by 6 minus 3 by 2. So you can try to solve this part.
Which one you are adding, ma'am? This one?
You will have to add the previous one for x lying with so fx for interval 1 to 2. You will have to add this part. So please try to do this part for x lying between. Okay. Try to
intervals should be added. Previous intervals should be added.
Yeah.
Just previous one. Just previous one.
Yes.
Yeah. Okay.
Okay.
The excuse me, the limit should be 0 to 2, na?
Where?
0 to 3. Here we have to add the previous one, na? X minus 1 by 3 plus 1 by 6. So the limit for the integration to be 0 to 2.
You can just put here x to be 2. It will be fine. So
only
if you
x equal to 2.
Yeah.
Ma'am, here we are adding the values of the interval, right? Not the whole function, right? Previous one, we are adding previous.
See, what is the definition of CDF? So CDF
up to that,
right? So it is, if you find for 2 to 3, so in 1 to 2, 0 to 1 is already added, right?
Yeah.
So if you just do for x lying between 1 to 2, that is sufficient.
Okay, then we should add x minus 1 by 3 plus 1 by 6.
Yeah, right.
We should add, na? Here.
Yeah.
Minus 3 by 2. How this minus 3 by 2 came? Last third term.
Can you try it on your own once?
Okay.
Yeah.
Okay.
So one part I've explained. Just try to do this.
Ma'am.
Excuse me, ma'am.
Yeah.
Ma'am, can you scroll up a little bit?
Yeah.
Excuse
Ma'am,
me, ma'am.
I'm sorry. Yeah, please go ahead.
Ma'am, can you tell the difference, like, ma'am, when we do for functional continuous random variable, so when we have to find probability density function, when we have to find continuous density, CDF and PDF, ma'am.
When to find, it will be mentioned in the question. If it says it says find PDF, it means you have your random variable is continuous. If it says PMF, it means your random variable is discrete.
Yes, ma'am. Ma'am, but no, ma'am, like in 4.6, ma'am, like in some activity, like they just gave to find probability. In some question they found PDF, and then some question they found the probability through CDF, ma'am. So how will know it was just given P?
Okay. So can you tell me the question number?
Yes, ma'am. I'll just tell you.
So yeah, you tell me the question number, write it there, and I will take it at the end. Okay.
Yes, ma'am.
So after this, I will just
Ma'am, I have a doubt on the question which you just explained. Can you please scroll up?
Yeah.
Ma'am, I could not follow after. So 0, 1, I got it. How we got x square by 6. and then to the right you have written, I mean, we would integrate 1 by 3, and which would give us x by 3, and then you are integrating it from 0 to 1 and not 1 to 2. Is it, I mean, I could not follow that, why it is 0 to 1 and not 2 by 3,
This is okay.
1 by 2.
Okay, so fx was for 0 to 1, it was x by 3. This is for 0 to 1. So if you write the CDF, so if you write fx of x, what do you write? You write probability x less than equal to x.
Right.
So if you have, see, you have the interval 0 to 1, 1 to 2. So if you have to find the CDF for 1 to 2, you will also have to add the probabilities for this interval, right?
Yeah, so for
is why we are adding that probability also.
I got that. My question is, so for 0 to 1 we had x square by 6, right? And then while calculating from 1 to 2, we need to add x square by 6 to this x by 3.
Yes.
Right? But you are integrating it from 0 to 1, x by 3 from 0 to 1.
So
my question,
no. See, after you do the integration, you got x by 3. Correct?
Yeah.
So for to avoid the confusion, let's say this is some random variable, some other variable y. So
Okay.
this is y by 3, and y is varying from 1 to x, right? So
Right.
y is varying from 1 to x. So this part will be x minus 1 by 3, right? Now this is for x lying between 1 to 2. But what about x lying between 0 to 1? So that probability we will have to add.
Mhm.
Right? So if you do the integration from 0 to 1 for x squared by 6. Okay. Okay. Right. So if you do the integration for x by 3, so our function was x by 3 from 0 to 1, then it will give you x squared by 6, right?
Yeah.
It will come out to be x squared by 6, and if you take the limit, it will be 1 upon 6.
Right.
Right? So this is what we are adding here.
Okay. Okay, but my question, I'm sorry, I could not follow. Like for the previous one, for x square by 6, we are calculating for the range 0 to 1, right? I mean, we integrated and then we calculated for 0 to 1, and that's how we got x square by 6.
Yes, right.
For the second one, now what I understood is we need to add the previous probability, which is 1 by 6, and which was integrated from 0 to 1, and that's how we got 1 by 6.
Yeah, right.
Right. The addition part, which is x1 by 3, x minus 1 by 3. My question is why it is not being integrated from 1 to 2.
Which part?
The second one. Yeah. Because
because we are finding fx CDF. We are finding CDF, not this is not PDF. I mean, you're trying to find the PDF, right? So you add it. I mean,
yes.
Okay, let's go to some problem from your activity question. I will just stop.
I'm not getting it. How you are getting that minus 3 by 2 coefficient extra term?
Yeah, that's what.
Sorry.
Ma'am, if I break it, I'll get it right. Integration 2 to 3. Like limit of the integration is 3 by 3 to 2 to 3. That is 4 by 3 minus x square by 6. Plus, I'll get 0 to 2 integration of the same.
Okay. Can you repeat again?
Okay, so I'll have 4x minus 3 minus x square by 6 for the range 2 to 3 minus 4x by 3 minus x square by 6 in the range 0 to 2. Actually, previous one will be 2 to x, correct?
Previous one is what? Sorry. Repeat again. Previous
so,
one is?
So 4x by 3 minus x square by 6 in the range 2 to x 3 to x, sorry.
2 to x. Yeah.
Yeah, 2 to x, sorry. 2 to x and minus the same thing in the range 0 to 2 plus.
You had fx to be this.
Yeah, then I have to
Period.
integrate this term also, right?
Yeah, you have to integrate this term. So if
then
you...
I'm getting 4x by 3 minus x square by 6.
Okay.
And the value of that in the range 2 to x.
Yeah, right. So this is what we're getting.
2 to x. Minus the same in the range, plus the same in the range 0 to 2. Correct?
Plus same in the range.
0 to
what do you
2.
mean by the same?
Plus
4x by 3 minus x square by 6 in the range 0 to 2.
So you just have to add this one.
Yeah, but ma'am, over here on the in the range of 1 to 2, how are we getting that x minus 1 by 3? It should be x by 3 only, no? Then we will plus 1 by 6 in it. It should be x plus 3 plus 1 by 6.
It is x minus 1 by 3 plus 1 by 6. That is what I explained.
Maybe you can solve this again neatly. It would
Yeah.
clarify all the doubts.
Wait, just finish this question and then we'll move to the functions of random variable. Yeah.
No, the same question I'm saying. If you can just explain it neatly, we can all
Yeah,
understand.
man.
There
We
are
not getting
doubts in this question
the
itself.
process. Yeah.
Okay, just wait.
I didn't get how it is getting x minus 1 by 3.
Yeah, man. Discretely we will define.
See, your fx is, I will take, it will go maximum till 9:30. I will try to wind up then. So fx was x by 3. This is 1 by 3 minus c by 3 plus 4 by 3 and 0. This is for x lying between 0 to 1. This is for 2 to 1. This is for 2 to 3. And it is otherwise, right? So for, if you have to find the CDF, then for the case x lying between 0 to 1.
Minus x by 3, right? Not c by 3.
Where?
Yeah, in the third one, 2 to 3, it should be x by 3.
Oh, sorry.
Instead
yes.
of c by 3. Yeah.
Yes.
Thank you.
Minus x.
Right. So
Yeah.
for x lying between 0 to 1, right? For x lying between 0 to 1, if you have to find the fx, it is going to be probability x less than equal to x. Okay. Let's not do this. So this is integral of fx of x dx 0 to x. So for to avoid the confusion, let's take here u and it is u. So x is varying from u is varying from 0 to x. So for the interval 0 to 1 we are talking about, and it is x by 3. So x by 3, so in place of x we are writing u. Okay, so u by 3 du, where u is varying from 0 to x. So this is going to be u squared by 6, 0 to x, and it will come out to be x squared by 6. So for
Yes,
0
ma'am.
to 1, it is x squared by 6. Now let's see. Now let's see for if your x lies between x lying between 1 to 2.
Yes, sir.
Yeah. So fx of x is going to be integral fx of u du from 1 to x, from 1 to x plus integral fx, the previous one. So we'll have to add for the previous interval because we are
directly
finding
add
the
x squared by
here.
6, right? Now we don't need to write that integral.
Yeah, we don't have to. Yeah, right. So if we have obtained x squared by 6, so you just do the limit from 0 to 1. So
Yeah, it will be 1 by 6.
yeah, so x square by 6, if you take the limit 0 to 1, it will be just 1 by 6. So if you solve this integral, we were getting x minus 1 by 3, and from there it is 1 by 6. So this is for this CDF is for x lying between 1 to 2. Is it okay?
Ma'am, but integral of 1 by 3 will be x by 3, no?
It is x by 3, but you have to take the limit from 1 to x.
Upper limit minus lower limit, right?
Yeah, right.
Got it.
Got it. So similarly, you try for 2 to 3. Okay, so let's not spend a lot of time in this.
Yeah.
For the second term, the limit will be 0 to 2 in that case, right?
Why 0 to 2?
I know.
1 to 2, we are already doing this side.
For 2 to 3, for the range x equals to 2 to 3, then I will integrate from 2 to x plus.
No, just 1 by 1 to 2 will be sufficient, no? Just.
No, ma'am.
Yeah,
For the
we
next
already
one,
added
2 to 3.
No, yeah, for 2 to 3, since in fx, where x lying between 1 to 2, you have already added the previous one for x lying between 0 to 1. Then why do you want to do it for 0 to 2? It has already been added there.
So, ma'am, what will be the term? This is the doubt actually for a lot of us. For 2 to 3.
For x lying between 2 to 3, so your fx is integral fx of u du, where x is lying from where u is lying from 2 to x, plus your x minus 1 by 3 plus 1 by 6, and this is from like you can just put 1 to 2.
Integrate from 1 to 2 only.
So if you solve this, okay, not one, okay, first solve this. So if you solve this, you will get 4x, what is the function? 4x by 3 minus x square by 6 minus x square by 6. So this was.
So the second term will be just the limit of the previous term and the value, right? CDF of 1 to 2 and the limit of 1 to 2, correct?
So basically, this is the CDF for
when the function is greater than 1.
When the function is greater than 1. What did you say?
This is the like fx du is the function when x is greater than 1 and less than some value that x will define later.
I'm not getting which part you are trying to say.
Saying when x is within 2 to 3, then my limit is 2 to x of fxu du, and the previous term when x is less than 2 and above some value, here in case which is 1, when x is lying between 1 to 2, the limit of that and the integration term, CDF of the previous.
Yes. So if you solve this, you will get 4x by 3 minus x square by 6 minus 8 by 3 minus 4 by 6. So this is 4x by 3 minus x square by 6 minus, let's say this is 18 by 6 plus 4 by 6, that we can write it as minus 12 by 6. It's 12 by 6. And if you solve this, you will get 1 by 3 plus 1 by 6, that is 1 by 2.
Yes, ma'am, minus 2. Now it is plus 1 by 2.
So
minus 3 by 2.
1 by 2 minus
minus 3 by 2.
Minus 3 by 2, right? Yeah. It is coming right? So yeah, so this will be minus 3 by 2. So you just have to integrate for this interval 2 to 3, and then you have to add the CDF for the previous intervals. Okay, so I hope the idea is clear.
Yeah, ma'am.
Yep.
Yeah.
Yeah.
So let's
But
move
this
to.
idea was not taken in the lecture. Piecewise CDF
It
was
was
not taken in any of the lectures.
It was taken in the lecture. If you look at the expectation and variance part, where he has calculated expectation variance, this part is done. You should watch it carefully.
Okay.
Yeah.
Okay.
Yeah.
Yeah, I'll watch it again then. Thank
Yeah.
you. Thank you.
Yeah.
Ma'am, could you please go through the activity questions of 4.7 functions of?
Just yeah, I'm going to explain functions of random variable, and then I can
Yeah, ma'am. Yeah, ma'am.
go.
That
Yeah, I
part is
can go
also.
for a few questions. Okay. So what does it say is like, if you have a random variable x, and its CDF is given as fx, and its PDF is small fx, and you have some function, g that is varying from r to r, then if that g is your another random variable y, and if you have to find the PDF or the CDF of y, how will you do it? So there is one very easy technique, like, but it works only for some particular cases. So this is monotonic differentiable function. So it says if x is your random variable, if x is a continuous random variable, and its PDF is, let's say, fx, and you have some function of x, gx, which is monotonic. If gx is monotonic in support of x, okay, then in that case, PDF of gx, that you can also represent it by another random variable y. So this can be given by fy of y equals fx of g inverse of y minus divided by g dash of g inverse of y. So this formula works for finding the PDF only in the case if gx is monotonic in support of x. So what is support of x? Support of x is all the values of x. Support of x is all the values of x for which probability of x is greater than 0. So this is what the definition of support is. So only if your gx is monotonic in the support, you will say this is your the PDF for the function of random variable is this one. So okay, so I will explain.
How
Yeah.
is this?
How will you know whether it's monotonic or not?
Yeah. So okay, let's say. So what do you understand by monotonic?
Either increasing or decreasing.
Or decreasing.
Either increasing or decreasing, right? So if I say your x, can you mute yourself? Yeah. So if I say x belongs to R, okay, and I am giving you a function of x, let's say y equals x square. So y is equal to x square. So let's say this is your x and this is your x square. Okay, so now let's say you have some function defined fx for which in the range of, let's say, minus infinity to infinity, let's say in the range minus infinity to infinity, your probability is greater than 0. So if I ask you whether y is monotonic in support of x or not, what will you say?
It's not monotonic, I think. In support.
Why do you think that?
I think it's
Because it's first
not monotonic.
decreasing
Yeah.
then increasing.
So for the range minus infinity to 0, it is decreasing, and for range 0 to infinity, it is increasing. Right? Please mute. So this is how you check. Okay, now if y equals x cube, can you tell me if it is monotonic or not?
Yes.
It is monotonic,
yes, ma'am.
right? Because it is increasing over r. So this is how you check whether it is monotonic or not. So for the problem, okay, I will take.
Ma'am, is there any way directly to, without plotting on the graph, we can say the function is increasing or decreasing or like that?
No, like only if you know, you can say that.
Graph plotting is required.
Only if you know what this function look like, then you can say this is identify whether it is monotonic or not.
How function will look like, ma'am? It's a mathematical method.
There are other methods that you will study in your maths 2 course, or maybe you have studied in maths 1 course. Okay, so you will study all that.
Okay, let us proceed.
So okay, so one problem I will take where it is where you can use this formula. So it is again the problem from your lecture. So it is given that x is exponential lambda. So what is the PDF for x? It is fx of x equals lambda e to the power minus lambda x for x greater than 0, 0 otherwise, right? Now I'm defining a function of random variable x, that is y equals x square. So can I use this monotonic differentiable function? Can I use this method to find the PDF?
Yes, ma'am.
No, ma'am. Ma'am, it's not monotonic increasing, no, ma'am.
Okay.
But it should be monotonic for the support of x.
Exponential.
Yes. So in this case, only for x greater than 0, you have the non-negative PDF, right? Otherwise, it is 0. So your graph, so this is your x square. So this is positive. Your fx is positive only for x greater than 0. So in this support, so in the support of x, your gx is increasing. So we can use this. So how will I find, how will I go about it? So we have to find the PDF of y. So we'll write fy of y to be equal to fx of g inverse of y divided by g dash of g inverse of y. Now how do you find g inverse of y? So see, your y equals x square. So write your x in terms of y. So x is going to be plus minus under root of y, right? So this is your g inverse of y. So you should write your x in terms of y, and that will be your g inverse y. Now you will have to find the derivative of x. So gx is x square. So what is g dash? It is 2x, right? Now just substitute it here. So if you substitute it here, it will be fx of g inverse y, that is plus minus under root of y divided by g dash of plus minus under
2
root
into
of
root y.
y, right? So what is fx of plus minus under root of y? So you just have to substitute in place of x here. In place of x, you will have to substitute plus minus root y. So you will get lambda e to the power minus lambda. So again, it is going to be plus minus under root of y divided by g dash of what is g inverse of y? Plus minus under root of y. So you see that whatever x is there, like if it is gx equals x square, so g dash of x will be 2 times x. So in this case, you have x to be root y, so it is going to be 2 root y. So it will become lambda e to the power plus minus lambda root y divided by 2 root y. So this is going to be your PDF for y. Is this clear?
Yes.
Yes, ma'am.
Okay.
And
So-
just the G dash part. How are we getting the G dash?
So let's write your gx. So what is gx?
Okay,
Gx
okay,
is-
G dash. Got it, got it, got it.
Got it, right? Yeah. Like
So why would it be e to the power plus minus? Because x support is already greater than 0. So consequently, when I'm doing y equal to x square and I'm doing g inverse y, would it not be only
okay, right. Right. You're right. Yeah. So x is also only positive. So yeah.
So just below the graph where we have written x is equal to plus minus, it will be only plus. Yeah.
Yeah, right. Okay.
Thanks.
So there it will.
In the formula also my mod is being taken, so I think it will be fine.
No. This is right. So your observation. Yeah. Thank you for this. So okay, I will take one example, which is where the function is not monotonic, and you'll have to solve in a general way.
Up until now, we've covered all the topics, right? For the quiz.
Sorry?
Up until now, we've covered all the topics for the quiz, right? So
Yeah.
till now.
Yeah. So this is the last topic. So, okay. So this question is from your activity problem. So you have, okay, x is uniform in -3 to 3, and y is defined as mod of x. So this is your g of x that is defined as mod of x. So how do we find this? So this is, if you plot the graph of mod x, so it will go from -3 to 3. So as you can see in the support, so what is the PDF of x? PDF of x is 1 upon b minus a. So this is going to be 1 upon 6. So from -3 to 3, it is 1 upon 6. The PDF is 1 upon 6. So in the support, your gx is not monotonic. So we cannot use that formula. So we'll go from the general method. So what should be the range of y?
0 to 3.
0 to 3, right? Because for this, for positive x, it is going to be y equals x, and for this side, it is y equals minus x. So it will go from, so y will vary from 0 to 3. Now if we find fx of x, sorry, fy, yeah. So now if we find fy of y, so this is going to be probability y less than equal to y. So what is y? Y is mod of x less than equal to y. This we can write it as, so if you split this, you can write x is less than equal to y and minus x is less than equal to y. So it means x lies between minus y to y. Now x is lying between 0 to 3. So how do you find the probability? You will integrate your, so this is nothing but you will integrate the PDF of x, fx of dx, from minus y to y. So this is going to be So what is fx? Fx is 1 by 6. So it is going to be 1 by 6 x, where x is varying from -y to y. So this is 2y by 6, that is y by 3, right? So this is the PDF, CDF that you will get for. So if you have to write the CDF, you will write for x less than -3, it is 0. Oh, sorry, you're talking about y. So for y less than 0, it is 0. For y lying between 0 to 3, it is y by 3, 1 otherwise. Any problem in this?
And when there is another kind of questions when we have to take care of the limit of range of x and y. Those questions create some problems. I mean, this is the simple one.
Okay, let's take another problem. I will go to the activity. So somebody was asking the activity problem. Can you tell me the question number?
Yes, ma'am.
Yeah.
Ma'am, I was hoping you could solve 3 onwards.
3 onwards, okay. So I think I have just solved question number 2. Let me see question number 3. Okay, so I will do one problem here. So okay, if you look at question number,
Actually, in the we haven't been able to discuss any of the problems in this activity session, even in any of the previous sessions.
There was one activity session conducted for week 4.
Yes, ma'am, but there the discussion only took place till 4.6.
Okay. All right. So okay, now question number 3rd. Okay, so I will ask you now how to do it. Okay. So this is the same question. So in place of now in place of -3 to 3, you have just -3 to 2. Okay. So I will draw my graph here. So this is your x, this is your 2, this is your -3. Okay. Can you tell me the range of y?
Y will take values from 0 to 3.
0 to 3, right? Now, okay. So if we have to write fy, so again we can write for 0 to, okay, before this.
Ma'am, I've obtained the CDF actually.
What?
I've been able to obtain the CDF, no issue there.
Okay, then if you have to find the PDF, then what will you do? How do you find
PDF.
what is the relation between PDF and CDF?
We can differentiate.
Differentiate. So whatever CDF you have obtained, you just differentiate it. So let's say in this problem, what is the answer? So okay, so this is 2y by 5. So you will get 2y by 5.
Sorry to interrupt. Could you actually solve this question? Find out the CDF as well.
Okay, so this is the last problem that I'm going to solve for such kind of problems. Like.
Okay, ma'am. Then I guess you can just go to the 5th one. I'm so sorry.
5th one. 5th one is again you can solve using the monotonic differentiable formula. Can you try it out with the formula? Because x cube is monotonic.
Okay.
Right? X cube is monotonic in your support. So you can use the formula here, right?
Okay, ma'am. And when we differentiate, we'll be differentiating cube root of what? Cube root of y, is it?
So you have here x is exponential lambda and y equals x cube. So your gx here is x cube. So your g dash is what? This is 3x square, right? And you have to write x in terms of y. So x is going to be y to the power 1 by 3, right? So if you find PDF for y, it is going to be fx of g inverse y, that is y to the power 1 by 3 divided by g dash of y to the power 1 by 3, right? So g dash is 3x. So g dash of x is 3x square. So what is g dash of y 1 by 3? It is 3x square. Sorry, it is, so whatever x is, it is just square. So in this case, x is y to the power 1 by 3. So it is
3y to the power 2 by 3.
y to the power 3y to the power 2 by 3, right? And fx you have already given, just substitute it there. This was easy. I will solve this. Yeah.
And one clarification, there was one question which asked to find the PDF of x without its signs, basically the second question. So we don't actually need to carry out any steps and calculations, right? It's just looking at the range of y, we can write the PDF.
Okay, question number 7.
222.
Question number 2. Yeah, that was quite easy. Like we have just solved, right?
Just because y can only take values from 0 to 3, you just write that.
Yeah.
Okay.
Okay, so this problem I will solve here. So our problem was x is uniform in -3, 2 and y is mod of x. Now you have to find the CDF for y. So let's draw the figure. So this is your x, this is your y. So -3, 2. Right. So it is clear, right? Like it is taking the value from 0 to 3. Y is taking the value from 0 to 3. So if let's say if y is taking the value between if x is taking the value between -3 to 2. Sorry, I said something wrong. So okay. So as you can see that at x equals -2, your y is going to be 2. But beyond x equals 2, your y is not taking any value, right? Like if you take x equals 3, your y is again 0. So you will have to split into two parts. Like now, if you take any y between 0 to 2, let's say you take any y here.
How this 3 came, ma'am? Value of y, maximum value 3?
Because your function is defined as y equals mod x.
Okay.
So
maximum, yeah, maximum value.
Right? How?
Yeah. Yeah.
Yeah. So okay. Okay. So beyond 2, your y is 0. So what we'll do is for the range 0 to 2, so for y lying between 0 to 2, you have to, if you find fy of y, so that is probability that x lying between y to -y to y, right? And this is nothing but integral 1/5 d dx. X is varying from -y to, so -y to y. So you can just you draw this line and then make a horizontal line. So for the range 0 to 2, if you take any y in between, let's say this is any y, So this is your minus y, this is your y. So if you do the integration, you will get 2y by 5. So this is for y lying between 0 to 2. Now if y is lying between 0 to 2 to 3, if y is lying between 2 to 3, we take any y between 2 to 3. Now y cannot go beyond 2. So this thing will restrict to minus y x till 2. So minus y to 1 by 5 dx. So that will be 2 plus y by 5.
How this minus y came out? Value?
The same as you got the previous one.
Okay.
Ma'am, can you explain why you divided the range?
Okay. So if you don't divide the range, like if you take 0 to 3 and if you take any y in between, okay. So let's say you don't divide the range and you take any y in between. Let's say I'm taking the y here. This is my y. So okay. So this y is not in the support of x, right? This will lie beyond 2. It is not in the support of x.
On the positive side, it is not there, but on the negative side.
Yeah, on the negative side is there, but what about the positive side? It is not there.
Yeah.
So if you break it into two intervals like 0 to 2, so if you make it, if you look at from 2 to 3, first for 0 to 2, then for 2 your y is going to be 2. So any y that you take between 0 to 2, it will always lie in the support.
Support of x, yeah.
Support of x, yeah. So that is why we split into two parts. So if you split, so in the first case it is again 1 by 5 minus 5 to y, so 2y by 5, and in the second case you'll have to take from 2 to 3.
So when we are taking the second case, y value between 2 to 3, that time around the probability of x less than equal to 2 or probability of x less than equal to minus 2?
Y should be minus 2. See, Fy of y is probability mod of x less than equal to y, and this is coming out to be minus y less than x less than y. But y is lying between 2 to 3.
Okay.
Right? So y cannot take, x cannot take the value, x cannot take the value beyond 2. Right?
Okay, so when we finally defining it, so if we have got
we can restrict it to 2 because your x will not lie beyond 2. So if this is our x, so we are saying minus y to y, and our x was lying between minus 3 to 2. Minus 3 to 2. Okay. So your x cannot lie beyond this range. So this y we can restrict to 2. Okay. So it's the same as what we have seen in the lecture also. So okay, I'll just show you that one. So there you had
question number 6.
Okay, it's not, try to do it on your own. Like I cannot do every question here. So this question,
I'm not getting this question.
okay, so one error is there. So in place of in the option in place of x, it should be ax plus b.
Which question, ma'am?
Question number 6. So this question you can check on Discord. I think all the questions are solved on Discord. So if you have problem, please go and look. So I have discussed with you the method. please try to solve it on your own. Like unless you solve, you won't be able to understand properly.
Ma'am,
try to do it on
so in this question, if it had been x uniform from -3 to 1, so we could have divided it into 0 to 1 and then 1 to 3, right?
0 to 1. Yeah, right.
Okay.
Okay, so this was the last topic from week 1 to 4. So whatever I had told you about the exam pattern in quizzes and mock, please please attend the tomorrow's mock and try to solve the problems. You will get an idea
with respect to tomorrow's mock, while I have not checked it, but in one of our groups, what we are seeing, stats and maths, one
are
of
clashing.
Yeah, so one of it is at 7 to 8, another is 7:30 to 8:30, something like that.
So
But
okay, maths is 7:30 to 8:30, stats is 8 to 9. So this is maths too, right?
yeah, so but since for diploma people who have a direct entry, both these courses are mandatory for us. We would have liked it to attend both the mock sessions. So would it be possible just half an hour
Yeah,
shift?
I will just check it. It should be possible. I will just put the announcement again. Yeah.
Okay, that will be really helpful. Thank you.
Yeah.
Excuse me, ma'am.
Yeah.
Ma'am, one calculation part of the question, ma'am, if you can just write down and help me out of this.
Calculation part. Okay. What topic it is?
Ma'am, expected value and variance.
Okay. Tell me.
Ma'am, from activity question number activity 4.8, the question is, ma'am, expected value is given to be 6 and variance is given to be 4.
Okay.
And ma'am, the function is uniform between A and B. Ma'am, I'm using the formulas A plus B by 2 equals to 6 and B minus A whole square by 12 equals to 4. But ma'am, answer is not coming out to be 24, which is given in activity.
Okay. You must have done some calculation mistake. Please.
Ma'am, I've tried it many times, but I'm not getting it.
Somebody has also solved it on Discourse. Can you please check?
Ma'am, the answer is wrong or something like that?
No, answer is not wrong. It is right.
Okay,
answer is
question
right.
has been solved on Discourse.
Yeah, right.
Okay. And ma'am, this question number 7 from activity 7. Ma'am, in this question, the function is not continuous.
Okay.
Because there is a discontinuity. Ma'am, for this kind of question, when the function is continuous, but at one point it is not continuous. This is a example of mixture function.
Mixed kind of distribution. Yeah.
Yes, ma'am. Yes, ma'am. Ma'am, in this kind of question, how should we approach to the question? I'm not getting this thing.
Okay. So wait. Let us speak forward.
Ma'am, activity 4.7, question number 7.
You can discuss the problems with your peers also. Like if you want to know the concept, it is fine. But for the problems, you can check on Discourse. I'm sure all the problems has been done there. So please do not ask the questions from assignments.
Are you opening these files from Discourse?
Ma'am, all these questions are solved on Discourse. Okay.
Yeah, most of them are solved on Discourse.
Ma'am, the file what you're seeing is from Discourse?
No, this is PPT's lecture slides.
Ma'am, we are going to have one more session on Friday, right?
Yeah, we are going to have one more session on Friday. So please try to solve problems on your own.
Okay.
Now, like you have 1 week left, so please do not try that somebody else solve the problems for you. So unless you solve it, you won't understand properly. So try to do it on your own.
4 days left, ma'am, not 1 week.
Yeah, 4 days left. Yeah. So you should practice. Try to practice problems. That will help. Yeah. So that's it for today's session. Okay. So Thursday, tomorrow you will have mock that we'll check the timings and confirm you guys on the announcement. Thursday you have a session with Professor Andrew from 7 to 9, and there will be one more mock session on Friday. So please attend the sessions if you have doubts. Okay. And try to practice more and more problems. That will be helpful.
Thank you.
Yeah, thank you all. So you can drop off now.
Thank you.
Thank you, ma'am.
Yeah, thank you.
Thanks, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you, ma'am.
Yeah, thank you. Karthik, can you close the session?